Hello guys, welcome again in blockchain learning series. This is the second video for blockchain. In this video we are going to learn how we can make a proof of work algorithm for our blockchain and how we can make difficult for getting a hash value. So just I'm modifying this one. Here I'm creating a nonce value, that integer type, and we know that in blockchain we require this nonce value to get the hash. Now I'm creating one more, you can say, file in this module blockchain, that would be proof of work. So I'm creating here the proof.go file, and here I'm creating a package, again blockchain package under this, and here I'm creating a structure. So I say type and I say proof of work, struct, and here I will create a block of block type, and I will create here the target of int type. We can say this is for big int. Big int type, like this. Target and block, like this. Now I set a difficulty label. So I say constant difficulty label is, here I say 40, and in blockchain difficulty label is 20, I think. So here we say difficulty level is 14. I can set any whatever you want to set, but here I'm taking as a 14. You can take 12, 16, 18, 13, whatever you want to take. So now I create a new function, say new proof. So I will create a proof of work, new proof, and here in this proof I want to pass a block on which I want to get this proof, and it will return the address of proof of work, like this. So here what I have, so proof of work, I need difficulty version. So I create a target and I give it here big dot new int, and here I am passing a 1. So I want to get the difficulty level target for my hash. So that would be target dot lsh. So I'm shifting toward the left side of this, and here I say unsigned int, and here I just 256 is the maximum length of hash. So I want to minus the difficulty level of this, like this. Now this, I think this is done. Now what I have to do, I have to create proof of work. So I say POW equal to address of proof of work, and here I pass the block, and second I say target, then I return this proof of work here. So I just, with the help of difficulty label, we get the value. If this is to 14, so minus 256 minus 14, so this would be my target value, and I'm shifting toward the left side, so it would be of the biggest integer value of 256 minus 14 character. That would be the, you can say, the target value for my hashing. So I will get my hash on the basis of this target. Now I say for init function, init data function for retrieving a data. So I say function, and I say here proof of work like this, and I say init data. I will initialize data here, so that data will return what it will return the byte of information like this. So init data, and in init data what I need the nonce value here, integer type, and here I will create a data of by using bytes dot join. From this I will create byte, and here I will add proof of work dot block dot data, that I need data here. Then I need proof of work dot block dot prev hash. For that previous hash we require joining, and then I need the int value, that nonce value, and then we need a difficulty value, and here I have to use byte for joining as empty. So the problem here is that we have to convert these integer into byte, and then we will return the data in byte format like this. So now I have to convert these nonce and difficulty label into bytes. So for that I am creating a function, one more function, and I say two bytes. So I'm converting into bytes, and here I'm passing a int, you can say num, and it would be int 64-bit, and it will return the bytes like this. Okay, and here I take var of int, it would be of big int, so I have to take buffer of new buff dot bytes like this. And I say bytes dot buffer like this. I need this. Now I need, so what we have to return the buffer also, buffer dot bytes I have to return, and now I have to convert this to, so I say binary error equal to binary dot write. Here I have to pass the buff, and here I have to pass binary dot big Indian and num here. So this will convert the number, and if there is a error checking here not equal to null, so here we can say fmt dot println, or we can say log dot fatal. Here I pass error like this, so it will convert into bytes, and here okay, it is function, so we return the value here byte. So now I have to pass this value to 2 bytes function. Here I have to pass it to byte, the function which I created 2 bytes. Okay, and same I have to pass this one also 2 bytes. Here I have to so I have to do line by line like this for easy to understand it. So what I do, I have to convert into int 64 like this. This one also I have to convert into int 64 like this. So we have converted the data on the basis of nonce value, difficulty level, and we have initialized the data, and data is here. So we have init data function also, we have converted also, we have new proof also. Now we have to calculate the hash value. So I'm creating one more function here, and in this function again power of work we are passing proof of work, and I say here the function, we can say get hash, or we can make it a run function, and it will return the int value nunch, and it will return the byte. Byte would be the hash value. So it will return the int value, the nunch value which is set for this, and it will run the this. So now proof of work is here. So I have to get a hash value, a nonce value. For that, what I have to do, I have to create a variable, and I say that would be your big int. I say init hash, initializing my hash value of big dot int like this. Now for this big int is here. Now I have to initializing a nonce value also, so I say nonce value equal to 0. Now I say for nonce value is less than to the math dot big int 64 like this. So here big int we require, and we have nonce value. For we say math dot max int 64. If it is less than this, then we have to perform this task, and I have to create one more variable. This is big int, that would be of hash of 32 byte, like this. Now in this loop, what I have to do, I have to get data on the basis of init data. We have a function proof of work, so POW dot init data, and here I have to pass the nonce value, that would be the 0 in a beginning. Then data will come and I will get the hash value for this data. Here I say SHA 256 dot sum 256, and here I pass the data, so I will have the hash value. Now I will convert this hash to byte, set bytes. I will pass here hash, like this. Now if init hash dot cmp compare with the target value, the target is of pow dot target, like this, and is equal to -1, then I have to break this. Okay, else I have to increase the value of nonce for getting the appropriate hash value, like this. And if I get the hash value, for loop is completed. This one is my for loop is completed. Then I say fmt dot println. I can just, and I can print here the hash value also, it is coming. So I can say fmt dot println or printf, and I say %x here, and I say hash, like this. I can print the hash value also. One by one the hash will get, and I will convert into bytes, and I will compare this, and I will return at the last the nonce value and hash value, that I will return. So nonce value and hash value I will return. So none is also, so we have run function also, we have init function also, we have convert this, we have new proof of work also. Now we have to test this. In previous block here, when I am creating a new block here, this hash is not required because we have converted the init function for that, so we are not using this. So I just make comment of this. Now here in new block, if block is created, so I have to pass here nonce value also at the beginning, is would be 0, like this. So now in place of get hash, we have to use the different thing. We have to use here the proof of work equal to new to call new proof, like this. I have to call this function here, this one new proof, and this function have the block which I am creating. So I will pass here the block, like this. so it will create power of work. Then proof of work is there. Now I will create a function run here. So I say proof of work dot run like this, and this run function will return the nonce value, and it will return the hash value like this. And after getting this, so I will say block dot hash equal to hash like this, and block dot nonce equal to nonce. So we have like this. This n should be capital like this. So we have nonce value, we have this value, we have block here. Okay, so everything is same now, just we have using the proof of work for getting a hash value. So I think everything is done now. If it may be error, but we just check here now that difficulty level is 14. So here I just go to blockchain folder, go run main.go, and you will see that it calculating the hash value. And remember that we have the complexity difficulty level is 14. So we have the 30 in the front of this. So I'm just increasing the difficulty level now. If I increase the difficulty level of Bitcoin, because Bitcoin have a difficulty level of 20, so if I say 20 and I just make it more difficult, so you see it will take time to decide the proof of work. So it's searching for proof of work. You can see it's a data mining which we have in blockchain. So it will take little bit of time because of the difficulty level. If I increase the level of difficulty, then it will take more time to generate a hash value blockchain. So it will take the maybe 4 to 5 minutes, and remember that it will take 40 in the front of the hash value. 40 would be there, then after that the hashing will start. So I just give you the demo, one hash value. You see we have a one hash value, this one, and I got this value after a 6 minute continuously running on my system. And on your system it may take more time also, because my system having a 20 GB of RAM and i5, so it taking 5 to 6 minutes. And similarly it take time for data mining in blockchain also. So I'm just closing this right now, and I just decrease the difficulty level to 16, and I save it and I run it once again. So it will take little bit of less time for generating the hash. You see it taking a less time. So as I decrease the difficulty level, it will take less time. As I increase the difficulty level, then it will take more time to generate a hash value. You see we have a genesis block, we have first block, second block, third block. So all the hashes has been generated here. So this is the thing, and I can do validate also. I can check whether my hash is validate or not. That I can also check. I can measure the difficulty level. So for that I can create one more function, and I say here proof of work like this, and here I say validate function, and it will return the bool value true or false. and the code for that would be the same which I use here for generating this one. The same code I will have this one. So I will copy paste it here, and I have a big int also, this one, like this. So I have this code also here. Now I just initialize this. No need to check, print this, and here for nunch value I will take here the proof of work, then block, then nunch value, the block on which I want to check this one, then data hash, and then here I say return the true or false value here. So this function will work as a validator. We can check from this function that my hash value is okay or not. So for that I can use this function also here. So one by one I can check proof of work. So what I do here, I say proof of work, new proof, and here I pass the block like this. This block I pass here, new proof, and I have to use this one as a block chain dot like this, and by using this pow fmt dot print ln, and I say pow dot validate like this. This is a function, so I check it is valid or not. So here I print check valid. If it would be true, if it would be true, then that means it's a valid block, otherwise it will say false. So check valid, we can say this, and once again I try to run this one again. CLS go run main. You see, one by one it's checking that true. That means this block is also true, this block is true, this block is true, this block is true. All blocks are true, means these are validated block. So we have checked this, that these are validated or not. So like this we can check whether our block is validate or not. So with the help of proof of work we can validate our hash value, and we have generated the hash value with some difficulty level. The by default difficulty level now is 16. So on the basis of 16 we have get the proof of work, and we have validated the proof of work, and we have shown you that how you can create a blockchain with proof of work using Go language. So I think you have learned lot more things about blockchain from this video and from the previous video also. If you have not seen the previous video, kindly see that video also. And thank you for watching my videos on my YouTube channel. If you really learn anything from this video, kindly promote my channel, subscribe my channel, share this video, like this video. Thank you for watching this video again.